All right, now question 5. So here we've got to find second partial derivatives. The function is pretty sort of simple. It's just a polynomial. So I guess the only challenge here is that uh, it's going to be quite a lot of calculations, right? So first of all, notice that there are four of them, but as a matter of fact, so fxy equals fyx, because the second partial derivatives can be computed in any order of differentiation, right? Um, so we've got to just find three second partial derivatives, and to do that, we need to begin with two first partial derivatives, right? So fx is what? So 4x squared. Differentiating it, we get basically 8x, right? Minus 8x y to the 4. 8. We're differentiating with respect to x, so we'll just get 8 times y to the 4. Then there's no x anymore, so that's it. So now partial derivative of f with respect to y. How do we do that? 4x squared, nothing, it's just 0, minus, okay, 8x times y to the 4. So differentiating y to the 4, we get 4y cubed. 4 times 8 is 32, so 32xy cubed, and we shouldn't forget about the minus sign, and plus 7y to the 5, so 7 times 5 is 35, I believe, y to the 4. Okay, now what is fxx? So to find fxx, we've got to begin with fx, and then we differentiate it with respect to x again, right? So we've got to begin here, and then we differentiate it with respect to x, and it's just 8. Right? So what is fxy? Now to find fxy, we can either begin with fx and then differentiate it with respect to y, or we can begin with fy and then differentiate it with respect to x. And the answer is going to be the same. So it's going to be minus 32y cubed. And now fyy. To find fyy, we've got to begin with fy, right? And then differentiate it with respect to y again. And so here we have y cubed. The differentiation of y cubed is 3y squared. 32 times 3 is minus, I guess, 32 times 3 is 60, 96 x y squared plus 35 y to the 4. So 35 times 4 is 140, I think, y cubed, right? So let me check if I got the numbers correctly. 8 minus 32 y cubed minus 96. Yeah, correct. Okay, that's it.